If you're an electronic hobbyist like me, then you might be familiar with this passive component called resistor. In this video, I will explain about a resistor which are often used in electronic circuits. First of all, let me introduce you the main concept behind the resistor known as resistance. Generally, inside a conductor, the free electrons will move in different directions, but when we apply some voltage, they move in a particular direction and thus we get current. The voltage that we apply will give motion to the electrons, but during their movement, they get collide with the other atoms. Due to this collision, the current decreases. This phenomenon of opposition of flow of electrons is simply known as resistance. The energy lost by the electrons during their collision will be dissipated in the form of heat. That's the reason why electronic gadgets become warm after they are used for a while. A resistor has a capability to limit the excess current flowing through it. They are available in different values from 1 ohm to million ohms. Their size also vary depending on their power rating. Apart from these fixed resistors, there are also variable resistors available in the market whose resistance can be adjusted up to a certain range. But what is the use of these resistors in building the circuits? Well, electronic components can be handled at a particular range of current. Beyond that, if we apply current, they will be destroyed like this. But if we use a resistor with a proper value, we can limit the excess current flowing through it. But how to know the proper value of resistor to be used in the circuit? Well, it depends on the component and circuit. But I can give you an example with a basic LED circuit so that you'll get an idea of choosing a resistor. Before you get started with any component, you need to check its datasheet to know its operating current and voltage. In my case, the maximum current drawn by LED is 20 milliamperes and its forward voltage is 2 volts. With that requirements, let's see the first case. Here, I connected my LED in series with a resistor to limit the excess current. Now, I need to find its value to limit the current up to 20 milliamperes. A voltage drop of 2 volts occurs at LED because its forward voltage is 2 volts. Now, I need to drop the remaining 7 volts across the resistor. By using Ohm's law, I'll get a resistance of 350 ohms. From the formula, we can see that to drop a voltage of 7 volts and limit the current to 20 milliamperes, the resistor required is 350 ohms. If you don't have a 350 ohm resistor, you can use a 330 ohm resistor. That's not an issue. And don't forget to take the current in amperes during calculation. One more thing is that at resistor, a power loss of 0.14 watts occurs. So, I need to choose a resistor with a power rating greater than that. Otherwise, the resistor blows up. Let's see the next case. Here, two LEDs are connected in parallel. In parallel, the current gets divided but the voltage remains constant. Now, I need to drop 7 volts across the resistor to limit the current to 40 milliamperes. From Ohm's law, the resistor that I got is 50 ohms. If you don't have a 50 ohm resistor, you can use 200 ohm resistors by connecting them in parallel. Now let's move to the final case. Here, I connected two LEDs in series with a resistor. Since the LEDs are in series, same current flows through them and at each LED, 2 volts will be dropped. I need to drop the extra 5 volts across the resistor to limit the current up to 20 milliamperes. So, from Ohm's law, I need a resistor of 250 ohms. You can use a 220 ohm resistor because it's hard to find a 250 ohm resistor. With that, let's end this video. If you are curious to know about electronic components and building the circuits, please don't forget to subscribe my channel.